9, writing polynomial functions and models. In your class, we finished this yesterday. We talked about turning points. I'm pretty sure we did. Not every class did, but in your class, we talked about turning points. I guess I'll type this because not everybody was here for this. And hearing me say something and seeing it type two different things. Does anybody remember what turning point theorem was trying to tell you? Okay. The degree of a polynomial is at least one more than the number turning points. That's turning point theorem. It's a really easy theorem. Count turning points, add one. Of course, 3 kids weren't in here yesterday, so turning point's new to them. But a turning point is where the slope changes sign. I have no idea what I wrote in your definition yesterday, but it's where the slope changes sign. That happens there and there. Slope goes from decreasing to increasing, and on the other one it goes from increasing to decreasing. Just changes its sign. There's 2 of them. All right, so Kaylee, can you see visually what a turning point is? Yeah, it's pretty simple. This thing has 2 of them. What do you know about the degree? At the least. It is at least an x cubed, right? And that's what this section's about. It's all about writing least degree polynomials. Not most degree, that'd be more work, just least possible to fit this graph. What else can we talk about? We can talk about end behavior. Before we actually start writing this thing, it'd be nice if we knew stuff about it. We can talk about end behavior. This thing starts its day nice and high and it ends the day nice and low. Even or odd? Odd. Evens are high, high, or low, low. Evens start and stop the same way. The odds are opposite. Because it's starting high and going low, is it negative or positive? It's negative. So end behavior is suggesting a negative x to the odd. We did go over that again yesterday. It was in the notes from I think maybe 5.2 or 5.3, and we reviewed over it yesterday briefly. So that kind of lines up with the at least x cubed part, doesn't it? Odd exponent, 3 is odd. All right, now let's talk about our zeros. Zeros are also known as what? X-intercepts. I see 3 of them. Makes sense, it's x cubed, fundamental theorem of algebra, all that good stuff. What's one of your zeros? X is -3. While I'm on this thing, I'm going to go ahead and talk some more about here. Does that cross or touch the x-axis? Is it crossing? Because it's a crossing, what's its multiplicity? 1. At least 1. All right. We've got another one at what? -1? Cross or touch? It's crossing. What's its multiplicity? At least 1. And then there's the last one, which is at x equals 4. Crossing or touching the x-axis? It's crossing. Take your pencil, draw along it. If your pencil crosses the x-axis as you draw, you crossed. All right. There's your zeros and your multiplicity. That's all the information we need now to start writing a function. What's the first letter of the alphabet? What's the first letter in all functions, actually? You're studying ax squared plus bx plus c, a parentheses x minus h squared plus k, a absolute value is x minus h plus k. All functions start with what letter? A. Even y equals mx plus b. Y equals mx plus b is actually taught in most places not with an m, but with an a. I kind of want to switch over to that too, but I have a hard time getting because it's just no slope. But all functions are just by default, they start with an A. First coefficient you see is always A. So when you start writing this function, you're going to have to figure out what A is. You're going to have to write always an A value. It's always a leading coefficient. That's what A is, leading coefficient. Start taking our zeros and making them factors. If the zero is at x minus equals -3, what's the factor? X plus 3. We just change signs, that's all we do. If there's a 0 at -1, if there's a 0 at 4. Now, what's the exponent in all of these factors because of multiplicity? That comes from the multiplicity. Multiplicity is the exponent. Ones are understood, so you don't have to put it down there. But I want you to realize that that's where the multiplicity is shown. It's shown as the exponent of the factor. All right, so this function is not done because what don't you know? You don't know A, right? You don't know your leading coefficient. We use that dude, we use that dude, we use that dude. What about this little guy? Why is it there? It's there to be used. That's all I can tell you. It's there to be used. What does it give you? It gives you an X and it gives you a Y, which is great because the equation you have right now has 3 unknowns, but if you knew 2 of them, could you find the third? That's how it works. To find an unknown, you've got to only have 1 of them. So everywhere you see f of x, what do you get to be? 24, because f of x is y. Everywhere you see an x, you get to be 0. Then the first time you plug in numbers. I'm sure of that. So you do the multiplication, you multiply those 3 little factors together. And what is attached to A? Bella, you sound so sad today. Yep. We're going to divide out. And when you get your number, that makes sense. We decided right here it was going to be negative, didn't we? Use little things like that. One of the reasons going over stuff like this, if somebody throws something at you multiple choice and you understand end behavior, you understand turning point theorem, you're almost done. You are almost done by understanding turning point theorem and end point behavior. Almost there. All right, so to actually write the equation, we just throw A in and we'll be done with it. So f of x would be a -2, first factor x plus 3, second factor x plus 1, and the last one, x minus 4. And that is the polynomial in factored form, which is really about as far as we take it now for 2. I would be shocked if anybody asked for that in a standard one. The average kid just couldn't do it. Not that hard though, is it? Boil, then distribute, and done. 3 minutes. All right, there's the first example. Any questions on it? No? You want to go home? Next Friday at 11 o'clock. Got here for 2.5 weeks. Second one. Talk about all the same stuff. How many TPs? TP is turning points. There are 3 turning points. 1, 2, 3. There's 3 TPs, which means you're x to what power? 4. At a minimum, at least. Now, x to the 4th doesn't necessarily mean you have 4 factors. X to the 4th means you have how many zeros? 4. That's fundamental theorem of algebra, which was talked about yesterday. That's what it means. It means there's at least 4 zeros. Doesn't mean there's 4 factors, 4 zeros. Because, look at the graph. You just looked at the graph and didn't know much. How many zeros would you tell me there were? 3, because you see 3 x-intercepts. So this is where multiplicity comes into play. Before I talk about multiplicity, though, I do want to talk about end behavior. Some of you will get why I like turning point theorem and why I like end behavior. It's literally because when you're testing, standardized testing, it's just how much it throws out the window just by knowing it. Start slow, ends low. Not positive, not off. Start slow, ends low. Quadratic.
Negative next to the even.
Yeah, negative x even. You've been graphing quadratics for maybe 2 months. That's x squared. High, make negative, low, low. This is a negative x to the even, which is lining up very well with our turning point theorem. All right, time to talk about your zeros. What's the first zero you see? -2. Cross or touch? That's cross. What's the multiplicity? 1.
You get that from.
You missed both days I talked about this. So I don't know what to tell you. You might have to go back and be the fourth video, fourth viewer. Okay, but you missed both days I talked about that. If you cross the x-axis, you have odd multiplicity. 1 is odd. If you touch it, 2. Twice. Touches twice. Or 4, 6, or 8. That's kind of how it works. All right, what's the next zero? -1. Crossing or touching the x-axis? Crossing. What's the multiplicity? 1. All right. The third zero. 1. Crossing or touching? It is a touch. Touching twice, we'll start with t's. The multiplicity is 2. Now, even though you only had 3 x-intercepts, how many zeros did you actually have? 4. That's done by adding the multiplicity. Never repeated 0. So it's all there. It's all good. You got the required number of zeros. Time to start writing your function. Just like the alphabet, all functions start with what letter? A. And take your zeros and make them factors. -2 is a 0. The factor is. And what's the understood exponent on that one? 1. You got x equals -1. What's the factor? X plus 1, and what's the understood exponent? 1. The last one is unique. And what's the exponent? 2. Multiplicity is demonstrated in the exponential space. Now, polynomial is where it shows up. And then we get to use that little point. 0, -4. And we'll figure out A. By the way, you already know A is negative, right? If you understand M behavior, you know that. If you don't understand M behavior, you probably will after a while. A lot of kids get M behavior. So everywhere I see f of x, what do I get to do? And everywhere I see x, 0. The y-intercept is just nice stuff, things like that. It just makes everything easy. Don't forget that last piece is squared. Very common mistake for kids to forget that square is there. I feel pretty confident that 0 plus 2 is 2. I have seen a kid type 0 plus stuff in a calculator before. Don't be that kid. Pretty confident 0 plus 1 is 1. How about a -1 squared? 1. You see those signs mistaken in there all the time. So there's a 2 attached to A, right? So what's the A value? -2. Now I can write my polynomial. F of x is a -2 times an x plus 2 times an x plus 1 times an x minus a 1 to the second power. And that's basically it for looking at graphs. It really is kind of easy. If you get multiple, and that's why I talked about multiplicity 3 days in a row. You can see it a couple times. It's pretty good. And it's pretty easy to look at graphs. And it's not a hard section. It's not. We have one more, and it's a TI-84 problem. I just finished actually making your test Monday. It was on the twin, so it's on the test. And you will need a TI-84 to do it. By the way, when you take a test in here, nobody says you have to start at 1, do 2, do 3, do 4, do 5, do 6. You're supposed to know where the easy stuff is. The reality of it. You're supposed to know where the easy stuff is and do it first, and this is easy. So I'd be on that whole thing. We have taken points and thrown them in a calculator in the past. Anybody know how we've done that? We've done lines of best fit. We've done quadratics of best fit. This one right here is a cubic of best fit. Most of the work is still going to be the same. Silence? Okay, you're going to press Stat.
Edit.
There you go. And it will be highlighted. What goes into list one? X's. Your X's, they're in the list one. Your X's are in list one. Your Y's are pushed into list two. Hopefully, unless dyslexia kicks in, you should be able to do that. No, are you sure you're okay? All right. I'm sure I've already done this before. That should be what you have. Anybody need more time to push your buttons? Okay, so go off recall here. After you put all your crap in, what'd you do? Stat calc, that's right.
Stat calc 6.
There's stat. All the cool stuff's under calc, stands for calculate. And in this case, because it says cubic, it's pretty obvious, isn't it? Cubic regression. Cubic rate. It's a pretty easy skill to do. Yeah. Press enter, type down to calculate. Press enter again. Ta-da! There it is. All right. There's your A value, your B value, your C value, and D value. Not hard to do. And hopefully that's starting to click on how to do that. I hope it is. Does everybody understand what you're going to put in front of X cubed? Are you sure? Okay. But I'm not going to write it out. Everybody get the same thing? That might be a more important question. Because if you didn't, there's a typo. That in the last two classes I'm not bothered to print, which is also a possibility. All right. This is not anything new. It's actually something old. It's just something I want to talk about again. Write a polynomial of least degree with leading coefficient of -4 that has zeros of 2 with a multiplicity of 3, 2i with a, I don't know, doesn't say, so a multiplicity of 1. And then 1 minus I and 2 plus square root 7. What do you guys remember about weird zeros? Conjugates, that's right, ratio. Weird zeros have conjugates. So if 2i is a 0, what's another one? -2i. Conjugate is formed by changing the sign of the weird piece. That's all you do. Whatever is weird, change its sign. How about 1 minus I? Is that weird? It means it has a what? Conjugate. What's the conjugate of 1 take away I? 1 plus I. 2 plus square root 7, that's weird. What's the conjugate? 2 minus. It's weird because you don't really know what it is. I'm not saying you can't push buttons in the calculator and figure out what it is. I'm just saying you don't really know what it is when you look at it. So it's kind of foreign and weird. That's something that bothers kids a lot. It does, bothers heck out of them. Let's see here. This isn't in this question, but what degree is the polynomial? Time for zeros. No, it's not at least. is, this is the list of zeros, it is 9. The first one happened 3 times, you gotta say 3. Then you got 2 more makes 5, 2 more makes 7, 2 more makes 9. Just add the zeros, okay? This is a 9th degree polynomial. It's x to the 9th. Doesn't mean it has 9 factors. It just means it has how many zeros? 9, all right? You guys okay with that? Count zeros, that's all you gotta do.
Where's the zeros at?
Those are the zeros. 2 has a multiplicity of 3. 2i was a 0. We found its conjugate, negative 2i, which is also a 0. Think about every time you do the quadratic formula. What's in that thing? Plus or minus. That's where it's coming from. You get a formula to think about it, that's where it's coming from.
And so there's actually 8 to get that.
This one happens 3 times. 3 plus 2 is 5. Add 2 more, you're at 7. Add 2 more, you're at 9. Just add them. All right, let's write this thing out. You probably need to write small. I actually need to start a little bit farther to the left. What's the leading coefficient? Negative 4. Our first 0 is 2. What's the factor? X minus 2. Where do you show off that multiplicity? And by cubing it as an exponent. Multiplicity is shown by writing an exponent. This is the only one that had a given multiplicity. That's the only one we've got to worry about having an exponent. 2i is a 0. What's the factor? Change signs. That's all you do. If negative 2i is a 0, what's the factor? X plus 2i. And here's where we start having issues. Suddenly we're throwing 2 things in here. Really? Or not. What happens to both of them when they enter parentheses? They will change signs. Like the first one is x minus 1 plus I. The second one is x minus 1 minus I. You just change signs. Huh?
It's just, that's high school chatter.
Okay, well anyways, you get to work on your twin tomorrow. We actually did the lesson. The lesson was the first 3 slides. What's up?